All right, ladies and gentlemen, for this lesson, you're going to need to get out your notes and go to 2.4. We will be evaluating and comparing functions. So by the end of this lesson, the student will be able to evaluate and compare functions at given values. So evaluate and compare functions at given values. Okay, so quick review. Write the symbol that means is less than. So that is this one. Okay, the alligator eats the bigger side. This side is smaller than this side. Write the symbol that means is greater than. It's the reverse. Okay, you go this way. This side is bigger than this side because the mouth wants to eat what's bigger. All right, so let's fill in the blanks with less than, equal to, or greater than. Go ahead and pause the video right now and fill in the blanks for which ones are greater than, less than, or equal to. Okay, so let's see. 5 is less than 2? No. 5 is equal to 2? No. 5 is greater than 2. There are 1, 2, 3, 4, 5 dots, and over here there are only 2. All right, if we look at number 4, it wants -10 and compare it to -4. Well, -10 is a bigger negative number, so that means that it's smaller than -4, so -10 is less than -4. And on number 5, 7 is equal to 7. Go to the next page in your notes. Feel free to pause the video at any time if you need more time to fill in. All right, let's take a look at this next example. We're evaluating these functions for the given value. All right, so number 6 says, given this function and this rule, find f of 4. So let's rewrite it. We're going to do f of 4 equals 3 times 4 plus 5. So we're going to simplify this side only. We're going to ignore the f of 4 because that's our answer. That's our output value. So 3 times 4 is 12 plus 5. We get 17. So f of 4 equals 17. All right, so now let's take a look at the next problem, number 7. It wants us to evaluate g of x equals -2x plus 1. There's your rule right here. And find g of 4. So we're going to take g, and we're going to plug in 4 in for x. So that's going to look like -2 times 4 plus 1. -2 times 4 is -8 plus 1. That evaluates out to be -7. So g of 4 is equal to -7. All right, let's try one more example, and I'm going to have you do 9 on your own. So then we have negative. We're going to take -2, and we're going to plug it in for x. So we have f of -2 equals negative from the problem, parentheses -2 for my x, minus 3. All right, negative and a negative make a positive. So I get +2 minus 3. These are opposite sign numbers, so I subtract them. 3 minus 2 is 1. Larger number is negative, so my answer is negative. So we say that f of 2 is -1. All right, go ahead and do number 9. Pause the video, do number 9. All right, so here's our answer for number 9. If you did it, good job. You'll see that the answer for number 9 should be h of -2 should equal -20. Let's check with now. Let's move on to number 4, and we are going to compare functions. We're going to do the same process that we did, but we're going to plug the same value 4 into two different functions. Okay, so it's pretty easy how we do that. We're going to take f of 4 and we're going to evaluate it. So that means 3 times 4 plus 5. 3 times 4 is 12 plus 5 is 17. So f of 4 is 17. Okay, now let's try g of x. We're going to take g of x. Actually, we're going to plug in, we're going to plug in 4 into g of 4. So we get negative 2 times 4 plus 1. Negative 2 times 4 is negative 8 plus 1. So g of 4 equals negative 7. All right, so now it says compare f of 4 to g of 4. So that means use less than, equal to, or greater than. Well, let's look. F of 4 was 17. G of 4 was negative 7. So is 17 less than, equal to, or greater than? It is greater than. So that means that f of 4 is greater than g of 4. And there is our correct answer. All right. Let's try another example. Here it wants us to compare these two functions. F of x equals negative x minus 3. And h of x equals 5x minus 10. So we're going to evaluate them at negative 2. So x is going to equal negative 2 on both of them. So we take f of negative 2 equals negative, a negative 2, minus 3. Negative and negative is a positive 2 minus 3, so negative 1. So f of negative 2 is negative 1. Let's try h of x. H of negative 2 equals 5 times negative 2 minus 10. 5 times negative 2 is negative 10 minus 10 is negative 20. So h of negative 2 equals negative 20. So let's try that out. We now have both of our values. So let's compare f of negative 2, which is negative 1, to h of 2, which is negative 20. Negative 1 is going to be greater than negative 20. So that means that f of negative 2 is greater than h of negative 2. All right, I want you to try this one on your own. I'll grade it when I come back. This one, grade it when we come back. And let's try this one. Okay, we looked at these already a little bit earlier in a previous lesson, so now let's try it. We have f of x equals x, and g of x equals negative x. F of x is greater than g of x is sometimes true and sometimes false. Give one example that makes the expression true and one example that makes it false. So if you get stuck, try all of these numbers. Test each one of these numbers. Okay, so let's try this one first. Let's try x and g of x. So we're going to take f of negative 1. That means that f of negative 1 equals, let's plug in for x, negative 1. All right, now let's do g of negative 1. G of negative 1. G of negative 1 equals negative from the formula, parentheses, negative 1. Here we got to remember that a negative times a negative is a positive. Okay, so let's see if our inequality is true. This one right there. Let's check. It says that f of x is greater than g of x. Well, our values for f of x was negative 1, and our value for g of x ended up being positive 1. So this negative 1 is greater than positive 1 is false. Okay, so we know that it is false when x equals negative 1. All right, now let's try 0. F of 0, let's plug that in. So f of 0 equals, plug it in for x, 0. So f of 0 is 0. And let's try g at 0. So g of 0 equals negative of 0. Well, 0 does, so g of 0 equals 0. Negative 0 is still 0. So let's set up our inequality again. All right, let's look at f of x in this case. Okay, it says that anything we plug in for f of 0 is going to be greater than g. So is 0 greater than 0? No again, so this one is false. So that means that x also this statement is false when x equals 0. Let's try 1. All right, so we're going to do f at 1. So f at 1 equals 1. Now let's do g at 1. So g at 1 equals negative 1. So negative of 1 is negative 1. So g at 1 is negative 1. So let's check my inequality again. F of positive 1 is going to be greater than g at 1. So if f at 1 is 1, g at 1 is negative 1. So this is a true statement. So the statement is true when x equals 1. Okay, let's take a look at number 9. Okay, so we're going to do f of x again and g of x. So let's make a little table here. Okay, and let's test out some values. Add in another little table. So this will be x. We'll make one for f of x, and then one for g of x, and then one for our inequality. F of x is greater than g of x. So this will be f of x. This one will be g of x. So again, we're going to try negative 1, 0, and 1. So let's plug in negative 1 into f of x. So that'll be, if I plug in f of negative 1, that equals, plug it in, negative 1. So our value is negative 1. Okay. Then we check g of x. So that's be g of negative 1 equals 1/2 of negative 1. Well, half of a negative 1 is negative 1/2. So is f of x greater than g of x? Is negative 1 greater than negative 1/2? The answer to that is no. The smaller the negative value, the bigger the number is considered. So negative 1/2 is greater than this. So false. So again, this statement is false when x equals negative 1. Let's try 0. Okay, so let's plug in f of 0 into x. So that means 0. And then let's do g of 0 equals 1/2 of 0. Half of 0 is still 0. So for g of x, or f of x and g of x, the values are 0. So is f of x greater than g of x? Is 0 greater than 0? False. Okay, so this is also false when x is equal to 0. Now let's check 1. All right, so we're going to plug in. We're going to take f of 1 is equal to, plug it in for x, and you get 1. Now we do g of 1, and we get 1/2 of 1. And 1/2 of 1 is a half. So g of 1 equals 1/2. So we plug in 1 and then 1/2. So let's check, is 1 greater than 1/2? And the answer to that is true. Okay, so when x equals 1, the statement is true. When it's not equal to, so when it's 1, 2, 3, 4, 5, 6, or when it's negative 1, 0, or anything negative, it's not going to be true. I want you to now log into Canvas and attempt and work on lesson 2.4. Okay, A and B. When you get done with when you get done with 2.4 A and B, you can go back and work on the other ones. Have a good weekend, and I will see you on Tuesday.